big one. Duncan with a little, can't remember, Folgers mixed in. I can't remember. Anyway, Jason, the big tractor power got me thinking. It's going to be warm. There. Got me thinking this morning. He put a picture up of a 7080 Ellis Charmers. First time I saw him was New York State Fair, back in the Progress Center, I believe it was. Sat back in the corner, all dialed up. Had diamond tread front tires, 30-something, 32-inch tires on the back, flat top tread. It was cool. I mean, it just caught my eye. Dad, can we go? You stay away from that thing. Okay. It's kind of how that was. I guess when you grow up in a family that doesn't have their head screwed on right, everything is considered by what can go wrong, not let's go look it over. It's a demonstrator, by the way. And it's a tractor. You know, if a young kid can break a tractor, please. But it's possible by that time, because I can't remember what year the 7080 came out, that my father may have been gone even. I can't remember the time frames of everything back then. But what got me to thinking was the 7000 series Alice Charmers, now 7010 and up, not the 7000 itself. That was a morphodite compared to the rest of the line. However, it was closer to the previous 100 series than it was any of the others. So it was, they should have built more off of that, but they didn't. They went and called Fiat. So 7010 and up, brown bellies, black bellies, but mostly the brown bellies had some problems. The black bellies were, they had fixed. And when they went to the black bellies, some of the models disappeared. 7030s and 50s are gone, I do believe, by the time they got to black bellies. And then they had the 7040s. I think 7010s and 20s they maintained, went to 7045, and then jumped to the 7060s and 7080s. The curious part was the 7010 and 20, the 7000 included, had the 6-cylinder 301 engine in it. Little bitty 4.9 liter, I think they called it, and had higher pressure injection, had a better Standardine pump on it. Now it's called Delphi. Used to be Rosamaster Standardine, now it's Delphi. And Deere uses a lot of those. Well, several companies used them back then. Oliver was one. Deere, Case stayed with Bosch. Seemed like there was another that used them. I think Minimo. It was an inexpensive pump that worked, distributor pump. Well, anyway, with the 7010s on up, but I'm going to speak specifically to the 7030s on up. Because the 7010s and 20s, there's a lot of problems they didn't have compared to the other tractors just because they were less horsepower. 7010 was running, I believe, 115 to 120, and the 7030 was, or 7020 was running around 130. Yeah, they had that little 301 punched right, and I mean, juice for all it had. And the funny part of it was, I had been online with some customers in years past. The 7020, you wouldn't think, still had a pretty good torque rise left over. So the 7000 they tuned down for some reason. I don't know why. There's a lot of people that hated the 7000, and I still don't know why. It didn't have all the, it had a 3-speed power shift in it. It was a good tractor. They fixed the transmission trouble they were having. I can't remember if it still had a 4-speed. It seems to me, I think they put a 5-speed in it, changed the shift teeth mechanism down on the gears. Not the gears themselves that mesh. They were fantastic in the old tractors. They made the transmission so narrow there was a very little but coarse shifter. So there wasn't a lot holding as far as surface area, and there wasn't enough space to chip anything off when you're grinding, which would happen quite often. So there were problems there, but they were gone in the 7000, just virtually gone. The only problem they had with the early 7000s was the foot clutch and the power shift transmission. The foot clutch would quite often go, because if you didn't take your power shift, which didn't matter to the clutch or the power shift, except the clutch didn't like the fact you might be starting in second or third in the power shift. And what they did with the black belly was semi-problematic, every time you stepped on the clutch, it would shift you down into first. So while you're stepping on the clutch, barreling along, and doo-doo, that wasn't popular. But if you remembered to downshift before you hit the clutch, you had a beautiful operating tractor. Why? First was your clutch pack. Yeah. Well, what they needed to do was not have a mechanical kick down. They needed a hydraulic detent. So when you stepped on the clutch, it dumped the clutch pressure. And when it did, you went back to first. So Oliver had a fix on that their own. The 3-speed, when you stepped on a clutch, well, there's no pressure. So you didn't have direct or high. True story. Started in low on the Sprague every time. It'd only take a couple of revolutions, build up pressure, and then the other 2 clutches would come on, whichever one you were in. But think about that. One of the reasons that thing survived was it always started in low. Both the hydropower and the hydraulic shift. And in the back, they had to make changes when they started putting horsepower out of them, because in the back they had that little bitty overdrive clutch. Little bitty. Worked. So in the Alice, what was their main problem with theirs? Well, when you get past the 7,000, 7010s and up, they had the same transmission, 20-speed power director, which was 5 on the floor, high-low range. And then you had a hydraulic power director, 2-speed. Similar idea to your old tractors, only the clutch disc was this monstrosity. High and low were huge. I mean, massive. And I do believe that did something similar, because they had a dump valve on it, and you would use the power director as your foot clutch. In those as well, on the flywheel, you had a torque limiter. You say those 7,000, yeah, the 7,000 black bellies had a torque limiter, and the clutch was low. The 7010 and on up with the power director, they used the power director. I do believe it dumped and went to low, and then once it was going, would shift into high if you had it. But I do believe that when you stepped on the clutch, click, if the mechanism wasn't rusted, it would shift back to low, and then you'd start up again and shift if you needed. But I can't remember precisely. These huge clutches, but on top of the flywheel or transmission housing right there in the front, the bell housing, was this little bitty valve. It handled everything. The bell cranks and connections were more troublesome than the unit itself. So they had very little trouble with that. In fact, I ran into 2 of them that they had one problem, in the cooler in the bottom of the radiator, just like a torque converter cooler or your car, would leak and water would get into the oil, more so than oil in the water, because it was a cooler circuit with very low pressure. And when you're working hard at 15 psi, could push antifreeze coolant into it. So that would cause more trouble in the transmission and the power director than anything else. It was almost a bulletproof setup, especially if they kept it original with a stick on the floor. Well, people didn't like the stick on the floor, so they moved it over to the side. Problematic. It worked, but the cables caused all kinds of trouble. And I believe that's what they did with the 8,000, because I think the 7,000 series, they kept the stick on the floor. What they should have done was the Ford deal. Moved it off to the side and still kept you with a stick. The cables worked, but you had to replace them every so often. Probably every 3 or 4 years, you had to replace the cables, and Alice charged a lot of money for them. A lot of money. But that gets you out of that. The power shift. The power shift would kick you out of 5th and 6th. Anywhere from 4th down, any one of those clutch packs could act as a clutch. So if you're up in 5th or 6th, you stepped on the clutch, it'd drop you down to 4th. And probably what you should do, if you were thinking and wanted for the longevity of any power shift, you go through the gears, bring it back down to 1st, and then stop if you have the space. You don't always have the space. But if you're thinking about it, it wasn't very problematic there either. But if you put a loader on one of those tractors, something 1 through 4, no problem. The reverse was tough enough for it, but the 426 engines from the 7030 up, they didn't have a problem with it. 7010 and 7020, you put it in reverse, you let up the clutch. It sounds even at idle, even with the throttle up a little bit. I mean, it bogged the engine terrible, because it suddenly was turning like 300 pounds of iron backwards to send the thing out. Big, long counter shaft at the bottom. Power shift was a monster. just a 14-inch clutches and massive housings that you had to see them to believe them. The biggest problem they had was if you didn't change oils often enough. You had to change your fluid and filters, I mean, once a year, twice a year. Didn't matter how much you used it because of moisture. Get fresh oil in there, clean filters every time, every year. Doesn't matter if you only put 100 hours on it. Once a year, every year, change it. Why? Because the oil sits there and settles out while the tractor's sitting. You're better off with it running. So that was one of their major problems. There was literal check balls in the outer housing. Mm-hmm. And what the idea was is the balls were open so that when you went to shift, that was part of the dampening. And as oil came in, it'd push the balls against a spring and up into a seat. And then as you shifted, the idea was they were to bleed off some of the pressure. So it would just, and when you were in neutral or whatever, any other speed, there'd be a very slight leak through the system, plus through the lube circuit, go right between the clutch plates and on out, and the piston was supposed to help bleed. Well, if it didn't bleed off well, then you had shift trouble, and they would quite often plug. The idea was good. How they carried it out, not so good. But when you cleaned it up and put it together, oh, they were sweet. First one I ever did, I put it together, and somehow, some way, there was such a little difference I missed going through a clutch disc. And as I was putting it together, there was a clunk, and I looked all over, couldn't figure it out. Everything was so heavy it didn't move. I put it in the tractor, and I got this funny vibration up and down, and the pressures for the clutches went up and down. And then I had an idea of what it was, so I ended up tearing it all back apart, setting it all, double checking the clutch pack, setting it all back up, set the bearings up, put it together, and it's a beautiful running rig. Power Shift's main problem was maintenance, and on the side was the aluminum valve body. The shift valve was an aluminum valve body. They had plungers and a rack. And as you pushed it, there were little nubs on the rack that would operate the plungers. Pretty bulletproof. Couldn't screw up the timing or shifting or any of that. Had a modulator valve and a pressure regulating valve and a cooler valve. All in the one deal. But it was aluminum. And without enough space in there, the aluminum actually would warp in the body in the middle. I sent one out to have the surfaces machined flat. Once they were machined flat, put it back together, repaired the rest of the transmission. It was beautiful. And what was happening was it'd warp, it'd stick the valves, but at the same time it blew out the gasket. And then they kept driving it until they destroyed it. Well, the original problem could have been fixed much less expensively. If you buy one of these tractors used with a power shift, my first advice is take the power, it's not that hard, it's right on the right side there, take the power shift valve right off. And then eyeball it inside, you'll be able to get some idea of the clutch disc while you're in there, and look in the bottom of the transmission. Look at that massive reverse countershaft in there. Just incredible. It was incredible. They put 115-20 horse through the thing. It looked like it'd take 120 to turn the transmission. But take that off and immediately tear it apart. Check your valve body. If you have a flat plate that has either been machined or you've got a marble lapping plate, get a hold of somebody and sand the buggers off and put it back together. And then make sure all your plungers are cleaned, and you can use Common or Benami, something without the heavy grit scrubber. Just mild, very mild pumice. Get in there and clean the things up with a little bit of oil, like 10W30 or something, and clean them up. Make sure they move smoothly. Polish out the bores if you have to. Little 3M pad or something. Just make sure the plungers move freely. And your other valves, your regulator, your modulator, and your cooler valve all work. Make sure your cooler is clear. One of the problems they had, I partially ran into, but nobody wanted to spend the money, was a cooler, was a restriction. Well, if there's too much restriction in the cooler, it backs up into the cooling system, backs up into the shift system. So when it's cold, if both of those pressures are too high, then your shift pressure is too high and you lose your modulation, and they don't work well that way. But sometimes to get your boss and farmers to spend that extra $500 to $1,000 for that cooler, ugh. I blew it out, cleaned it out best I could, put it back together, made sure everything was clear all the way back. Didn't matter. Needed to be replaced. So, but still, when I got done, the system worked well. Once everything got warmed up to temperature, then it was flowing, and I had in the range where they were supposed to be. So that was on your transmission when you're working with that. It's somewhat self-contained. I think that one operates off there's 3 pumps there. And I think it operates off the G-rotor pump that's further inside the transmission, which is also a tranny lube pump and rear end lube pump. And then there's the gear pump for your steering and one other function, which might be the transmission because it has a priority valve or flow divider. I'd have to go back and look. And then there's your piston pump, which runs your 3-point and your remotes. The piston pump is problematic only in that maintenance and, how do I describe it? It was a PFC pump, pressure flow compensated, which is kind of a misnomer in a way, but it's true because others will tell you it's a load sensing pump. It's not. It is not a true load sensing pump. When you get on your newer tractors and you make your adjustments, you have a load sensing pump because you're telling the pump what to do directly through a circuit. But still, you could be running a PFC pump. Problem with a PFC pump is that when the pump is not always at pressure, it drops back to about 500 psi idle or neutral pressure. Nothing's being used. It shuts the pump down, so it only takes a couple of horsepower to run the thing. It just sits there and spins and maintains 500 psi deadheaded against it's a closed center system. That's it. Now you pull a lever, it changes the unloader, which is your low pressure adjustment valve, pops that, and now it turns the pump on. Instead of bleeding the piston off and adjusting it here, now you hit it and it closes off the circuit or opens the circuit, smashes the swash plate full bore, and now you're on your normal pressure compensator. So one of the problems they had was John Deere. Guys would tie the lever on a John Deere chopper with the hydraulic controls. They would tie the hydraulic lever. Well, the pump's on 100% of the time now, and the system's not built for that. That was a mistake they made. And if you got into some of the air planters, one of the problems they had there was it was running continuously, which everything else is fine, including the pump, if you have sufficient cooling. That's why a lot of the planters that went hydraulic also had electric versions available. Put on a Monster 130, 50 amp alternator, run a wire back, then run the fans and everything with that. Made more sense, but it could be problematic and fire related as well. So that's one of the problems they had with that PFC system. It just wasn't fully developed for anything but running rams and short-term motors. So if you wanted to run a continuous motor, it could be problematic. Why? Because it was trying to maintain 2,500 psi. There was no flow control. Once you're on pressure compensator, you've turned on a function. It's trying to maintain 2,500 psi all the time. And it'll send out up to its full flow rate continuously. Well, the other part is you have your John Deere controls on, you tied your lever. As soon as you tied your lever, now you have the problem with your unloader. Your pump isn't moving much, but your pump is at 2,500 psi continuously. There's nothing there to cool it down. They didn't have anything to run fluid through the pump body to keep it cool except the pump leakage itself. So because of that, it was problematic to keep the pump cool. They didn't design the system properly. However, for their day, way ahead. You say, well, what's the difference with the John Deere system is they were set up and designed to operate specifically at 2,500 psi, continuously. That is a strictly pressure compensated pump. Oliver's and White's were similar, pressure compensated pumps. They were designed to run at that pressure with coolers and bypasses and all this other stuff. But the Alice, they could overheat the hydraulics now and then. But it was pretty rare, as far as I can remember. A lot of that probably came from abused power shifts or some other form in the thing, because there is a hydraulic cooler on them, and a fairly good one. The transmission fluid is the same. So when it's running through your tranny going through the cooler up front, plus I had a hydraulic cooler, Catch my drift? There shouldn't have been a problem, but there quite often was. The John Deere was the main one that I ran into with one fellow, and I said, well, there's a fix for it. And he said, what's that? And I said, I put a solenoid valve in there. What do you mean? So when you pull a lever, it activates a system in a valve and tells the pump to turn on. Well, the only thing I do is put in an electronic solenoid to do the same thing. What do you mean? I said, put it in the system like your valve's there and plumb it in so that you pull and pressure goes to it, just like the valve. Every time you activate a function, it hits the solenoid, turns the pump on. When you're done with the function, the pump goes back to standby. So how often are you going to change it? Most of the time you don't, so why would you turn it on the whole time anyway? The actual easiest fix would have been to stack which remote you're using and to stack switches on it. And I do believe I gave him both of those alternatives. Well, that's crazy. I just want to... Well, you'd have a stack switches up here. Click a switch, move your lever. Click a switch, move your lever. You only have to click the function on. But if you needed to do it the other way, that's fine too. Then you click the switch whichever way you want it. Click, 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 or this way and pull the lever. Click, pull the lever. Click, pull the lever. Or push, whichever way you want to set up for. You can't miss, but I couldn't convince him. Said you put a John Deere product designed for one type of system on another. And he started screaming, they're both closed center. They are, but built to operate different. So that was one unique problem we got with it. But still, with your proper maintenance, the 3-point hitch and the remotes, I mean, smooth, touch control, it was nice. The only problem I think they would have had is the detents were a little stiff, but farmers back then loved a stiff detent. You didn't feather much, but they could once you got used to them. What else do we have with it? Main problems that these tractors had, let's go into that. Some guys complained about PTO, but there was some stuff you had to screw around with a PTO to replace the clutches, but overall, not much PTO trouble in the Northeast where I was. The highest usage in the United States for PTO in the past, 70s, 80s, even the 90s, was here in the Northeast. So later on, when they're running grain carts and some other stuff in other parts of the country off PTO, now maybe now because of the higher horsepower stuff. But back then, we were doing the chopping almost year round. The only break they took was in the winter, and even then, some guys were still chopping corn. Depending on what the ground was, they had to leave it sit. So that's when they come up way back with a double use corn. You could get it so it would be silage or grain. And there was some complaint with that, but not much. The biggest thing I think they liked about it was, even though it was inconvenient, Alice had taken their 2-speed PTOs and made it so you pull it out, turn it, and bolt it. You couldn't screw it up because it would only fit one way, and you could only put the screws in one way. Then it made it simpler. If there was any problem, the bolts came loose and it was your fault. It wasn't like a snap ring and thing came undone. So, and the amount of trouble I heard with that was so rare that it was incredible, because once you reach past a certain point, you're 1,000 only PTO anyway, or should be. And I would think once you hit 100 horsepower and up, they should be locking it off at 1,000 RPM PTO. And then once you pass, I forgot what it was, 150 or something, there's category 2. Where they go from 1 3/8 21 spline to 1 3/4 20 spline. No way to mix them up. And that was your heavy duty HD spline 1,000 RPM PTO, which is barely enough when you start getting over 200 horse. But on the Alice, we didn't have much trouble with that. Didn't have much trouble with 3-point hitch in general, any of that, unless a valve got rusty and stuck. Bad cables. The biggest problem with the 7000 series is bad cables to any of the controls. Any of the shifters, any of the hydraulics, any of it. All was related to bad cables that either A, they'd never lubed, or B, put cheap cables on, or C, they just needed to be replaced every so often and adjusted. It was a pain in the butt. Alice charged a lot of money for them because they were all made to fit. And then later on, they had cable casings at a lot of different parts outlets where they would build a cable to fit, or you could call in and have a cable built for half the money. Well worth it. Especially for your high-low and reverse and park. Well worth it. You get that little lever set up so that's working well. Oh, it wasn't reverse, it was high-low and park. And when you get that set up working well, because that was kind of a convoluted thing they did, there were some farmers that went all the way to make a special pipe to go over that back little shifter. And they said the instant they put the pipe on there, they never wanted the cables fixed again. They said if Alice had just put 2 sticks out of the ground, similar to what Ford and some of the others had done, they said they would have been thrilled with it. That was the main complaint about the tractors was shift cables, even more so than hydraulics, PTO, or any of it. But cables was their main problem. However, cables solved a lot of problems that other tractors had, links and cotter pins and building linkage all the way down through here. You couldn't get access to anything. So that's kind of a two-edged sword, but that was one of their main problems, especially with shifting. Destroy your park because you can't get it properly into park. When you pull the lever over, there was an arm that was activated, and the arm had to make a major swing to pull the lever over, and then you could get a little stick back in park. Well, the plate would come loose. They just built it too cheap. If they had actually built it properly, it would have worked beautifully. And what do I mean? There, they should have used a link and a stick, but they didn't. They didn't. So nothing I can tell you about there. They were trying to keep it short shift so they could put it in the console. What did that mean? That meant short stick. That meant then the plate wasn't heavy enough. The plate should have been mounted solid to the stick. Somehow better than just one bolt and a couple of flats. 2 bolts maybe and the flats. Made it wider at the top. Something different. And if they'd have fixed that alone, then the cable problem might have disappeared. But still, you had to move the lever over, and they're trying to keep it short stroke. They should not have. They should have made it a wider stroke. But that was one of their major malfunctions, was the cables and such. Cable to the power shift was moving all the time, really wasn't a problem. You didn't have a cable for your 2-speed. Your power director was a long shaft where you'd step on your pedal. And occasionally that would get too loose and it wouldn't work right. That was hydraulic detent, as I remember. So if you shut the tractor off, it went back to low. So I do believe that when you stepped on a clutch, it went back to low. So, but that's just what I remember. A lot of people, they turned up the pressure on the power director on one tractor that was a 7050, and they punched the engine to running 250 horse or better. They said at one point they knew it was turning 300, and they're using it for out of the field tractor pulls. And it was still alive after one overhaul, well after 5,000 hours. So they had to take an N14 Cummins starter, big cam, and redesign it, which it almost bolted directly in the tractor, as I remember. That was handy. Big moose. Big. Something they should have put on there in the first place, because they had 4 batteries in a lot of these tractors. The compression was too dang low in the early engines, 14.5, 15 to 1, when they should have been running 15.5, 16, 17s. But without the electronic controls on some of the systems, it was kind of problematic. And they were looking for room for fuel and air. Lower compression, bigger space, more air. When you compress it, your actual compression pressure can go higher with a turbo. Sounds counterintuitive, but it's true. Ask some of the tractor pullers why they go down 10, 11 to 1 to start those things up, and blue smoke fogs out of there because it can't completely burn. There's not enough heat. There's enough heat to fire to run the engine, but that's one of the reasons they take so long coming up. That pump will flood the engine out with fuel pouring in there. Not enough heat, so they have to keep going to build heat. That's why some of them that they're on a governor. There's no doubt about that. But at the same time, they're trying to get it slowly to come up without choking itself out, get some heat in it. Then they have to get enough heat in it once it starts to pull. That's one of the other things they have to do, is bring the load on to get the heat up. Well, same idea. Alice did that in the field, and that's one of the reasons that those guys and Cummins of the 80s and 70s quite often would fog, especially in cold weather. And then they come up with step timing control and Cummins and timing control to get rid of the smoke. Yeah. So that's one of the reasons that Alice had starting trouble. Well, if they put the big starter on there and you had two good batteries, that would whirl it over so fast that it would build more pressure, more heat in the combustion chamber from that pressure and air that got in there, and turning fast enough to ram it harder that it would start. That's why it's so critical to have these things set up to work properly. Check all your battery cables every fall and spring. Why fall and spring? Well, fall because you're coming into winter. Make sure you have the connections and your batteries all test good. Okay? Replace batteries in pairs always if you have two or more. Never one at a time. Yeah, but no. The only way I would say do that is you find one you think is good. Well, put it on your shelf and pay the return fee, the recycle fee. And then make sure it's trickle charged continuously. Put two new batteries in, return the one. And then watch it later when one of those two batteries has the same problem. Now you got to start thinking you have wiring that you should have repaired and replaced anyway. But they may have other trouble. Well, take the good battery of that pair, put it on the shelf with that used battery, put another new pair in, trickle charge the two of them and test them. If either one they show up good and you need two more batteries, well, put those down on the second shelf for the 4 battery tractors. Backups. But test them continuously, because when a battery goes bad, it can discharge the others and destroy a stack of batteries. That's why I say replace them in pairs. You say, yeah, but you're correct. Yeah, but one bad battery in a stack of 4 can destroy all 4. How does it do that? Well, two things. It's either hypercharged, so the other guys are working harder because they'll hold too high a voltage, or the most often is they short internally, or they can't hold a charge, and they will cause a problem with continuously sucking down the other 3 batteries. The hypercharge, they can take the alternator to a higher level trying to charge it, because most of those older alternators are not very, how can we say it, specific. They generally go by restriction, resistance, so if the battery voltage's total is higher, it'll jack it. The other one is, well, you're not 24 volts, so you don't have that problem. Last but not least on these tractors is people hated to change the injection. Oh, 2 things left. One of them is the fuel pump itself would wear. In the back end of that pump is a vane pump that pressurizes the body of the pump to fill the pistons. That pressure goes up and down with the demand on your throttle and such. Well, what can happen is it sucks from the saddle tank up to the pump. Well, it gets to the point where it's worn, it'll develop pressure, but it starts to allow things to leak back because the return side is above tank. And the other part is it can't draw as well as it can push. That's the same with any pump. Very few vane pumps pull better, but still, they don't pull as well when they're worn. So as they get worn on the bottom, before you replace the pump, what we have done is a lot of guys put rattle pumps on them when they start getting up to 4,000 hours or better, 5,000, 6,000. And you're noticing it's just not quite the same. Well, rather than changing everything, you go through, make sure there's no air leaks anywhere, there's no restrictions, because some of these tractors had plastic lines on them with plastic bungs, and there was no sleeve in there, so it would crush it down to restrict the flow, and it would be an air leak on top of that. So it was a mess. I can't tell you, probably 3/4 of tractors I worked on of this 7,000 vintage and even late 200s series, they had that problem, those stupid plastic lines. No, you can use the plastic line. You can have the nylon ferrule or use a rubber ferrule. It doesn't matter there. But it's got to have that brass sleeve that goes in there to keep so that the ferrule has something to crush on. The plastic won't hold. Well, see, well, the rubber holds it fine. No, it doesn't. It does the same thing, just not quite as bad. You've got to have that sleeve in there or something firm. And the idea of the sleeve is, as it goes up against the end, you put the end in the fitting, the sleeve stays in the line. Ferrule around the outside holds the line in place with a nut, and you're golden. So I cut off probably, I don't know, 20 or 30, 40 lines in a 5-year period. It was a lot of stuff I had to repair. Worst is the guys didn't complain about any problem until all of a sudden you're out in the middle of a field out of Fonda, New York, up on top of a hill, probably 1,400 feet elevation on the west side of the hill, and the wind is blowing through from the northwest, just howling in your face. and it's 10 degrees outside, and the fuel gel, because of that restriction, it all plugged up right there. So there was quite a few of those. I didn't have any sleeve to put in there, so I cut the thing off, fought the ferrule back on, put it back on, and got him going. Get it out of field to go back up and repair his lines. You say replace it with rubber? Nah, it's a lot of doing, but you could. It would work. But anyway, I had to put rubber on some of them, picking off the saddle tank. On the side of the saddle tank, there was a plate on the mounting where I was able to put the little pump, and you put a screen on the inlet of the pump, as big as you can. Inline screen is better. You can screw one on the end of it, but the volume of that, it's kind of iffy. But they do work, but you have to be sure it's a screen, not a filter. I can't emphasize that enough. Even though there's a lot of head pressure, you're looking for something enough of a screen to protect the pump. That's all you care about. You don't want to filter the system. You just want enough the material that you know crap's going to go through there. Then always buy several of the filters. Get me? Because there's stuff in the bottom of that tank that's going to be moving that didn't move before. And that little pump will send it up there. You only need 0 to 3 psi. That's plenty. But if you got higher, 4 or 5, the pump body goes up into the 150 area. So if you got one that's running 5 or 10 psi, that's a bit much, but it'll still fly. It'll work. They have a regulator in the pump. It'll handle it. But keep it down low as you can. You just want to get fuel to it. You're looking to help it. You're not looking to override it. I did that in a 7045 and I think one other tractor. And the guy had a jacked 1066 that was turning, on the dyno was turning well over 150 horsepower. 7040s rated 140. He said he parked his 1066. Didn't even come close. He says, I hit a wad with the Alice, it barks and keeps right on going. Doesn't even slow down hardly. He says, I cannot believe the power of that tractor. He says, it's a lot nicer to drive. That was a 7040. It wasn't even a 7045 with all the updates and such. Just to give you an idea, 7045 was an upgraded 7030, but they hadn't fixed all their problems yet. So those are the main things. Some of the rest of you are going to say you had this problem with the rear end or that problem with something else. All of that's possible. But those are the main problems I saw with these tractors. The other one I had that was an oddball, just to keep in mind for some of you. If you're rebuilding an engine by yourself, the sleeves have 3 O-rings in the bottom. And I had it happen one time, and it was 6 months later that the problem showed up. And I found it accidentally later while the engine squeaked on the guy, and he fired it right back up. He'd gotten into a massive mud hole. And this 7040, I believe it was, might have been a 30. And the thing lugged and snorted right on down, and he says, just about stalled the engine. Well, he noticed the engine stalled, and it shouldn't have. So he fired it right back up, tried it again. We brought it in and found out that there was a problem internal. I pulled the pistons out and found one scuffed. And what had happened was with the 3 O-rings, the center O-ring rolled and cut. It cut because it came out of the groove and was laying next to the bottom one, or the upper one. And what had happened was it was there and pushed in 1/2 thousandths clearance difference. 2.5 is the minimum. Pushed it in so there was 2. And under extreme, extended load, the piston grabbed. So your lubricant, putting it together, is more important than you might think. And I'd be tempted to be. The problem you have is if you start using things like Vaseline, the problem you have is it acts like grease. And if you put too much on, that alone will get under the O-ring and push it out and make it much more difficult. Always put your O-rings on dry so it holds in the groove. And I think that was one of the mistakes I might have made. But anyway, then you lightly lube the outside, especially if you're using some form of grease. Don't hyper lube it. And then grease down in the inside, and then when you go to put it in, by hand only. Anything that feels funky, always have an extra 1 or 2 sets of sleeve O-rings available. Pull it out and check. Don't, because now's the time. Make sure. And then do your measurements. I did my measurements before. Everything seemed okay. But after it ran for a while, and me, I might have just measured across the thrust surfaces. And the thing of it was, I was the only guy in probably a half a dozen shops in the Northeast that once they put the sleeves in would have measured anything. They all said the same thing. Comes from the factory set. Throw it together. Strangely enough, because I measured some things on another engine similar problem, the factory came and covered a minor screw up because they didn't send a bulletin out for a change that had happened. So having measurements recorded can save your fan, and I mean top, middle, and bottom. Brand new sleeve, yeah. But if the sleeve was made out of round and fit in there funky, and might have caused an O-ring to be cut, they'll cover it. And the boss will be much happier. Because that second one I got out of, when the boss came out all mad and furious, and I said, no, when I put it together, this O-ring rolled up. He says, you're kidding me. And I showed it to him. And he says, are you kidding me? That little thing? And I said, half thousandths less. He says, yeah, but this is 6 months later, so they split the bill with the customer. He was happy as a clam. He says, well, you guys covered it. So those are the things I remember there. Those are two of them. What's another? Oh, the engine oil cooler that weeps out the little hole in the end once in a while. That's why there's little weep holes there, is to keep oil pressure from pushing into the coolant. You see them weep, pull it apart, clean them, put new O-rings in, change the oil cooler. Make no questions about it because of expense, or have it sent out and tested. You've got to. Just don't even take a second thought about it. On the newer engines I have worked on in the past 20 years, one of the major problems we have is engine oil coolers leaking. And even worse than that, a similar idea, EGR coolers, exhaust gas recirculators on the diesels, will leak coolant into them and send it through the engine. You can get some funky codes out of that, and some funky smoke, and the DPF plugging all the time. Yes, diesel exhaust filters. DPF, diesel particulate filters. Yeah, it screws things up going through the engine, sends screwed up smoke burning out, catches it. Oh, yeah, that's why I say, you got an oil leak, don't let it push coolant into the oil. Don't let oil be pushed into the coolant, because either one has catastrophic results. You know that. But just to remind you, the worst is coolant in the oil. Your bearings are done. If you're doing sampling, and you check your samples, and oil sampling, please do at least once a year, once every couple of years. Always do some oil sampling on your engines, hydraulics, because they're high trans together. The transmission is almost more important than checking in the hydraulics, obviously, but still, if they're separate, check the two. But in the engine, why I say is if there's any coolant, because people complain. I've had bosses for the last 30 years gripe if you've done a engine oil sample and they come out and say, they'll look at you and say, well, how much coolant? What do you mean? No, none. I say, what do you mean? Any coolant detected is bad. And yeah, but you got to have a percent. And they just argue with you. They just got to fight. They want that number. There is no number. None is supposed to be there. I've asked questions like that before on another one, on some other things. There's no spec because none is supposed to be there. Coolant's in your oil. The first thing you do is pull a pan and replace your bearings immediately. So that's crazy. No, but if you have the old tri-metal bearings, the top starts peeling off. And when it does, it rolls over. When it starts to roll over, it starts tearing things up. You want to pay for that $5,000 or $10,000 crankshaft? Go ahead. It's worth every effort you can to replace those bearings. You can avoid trouble later. You can avoid trouble up with cooling on the pistons because they're designed to be oil cooled from the backside, not water or ethylene glycol cooled. Okay? You can get a lot of stuff. Steam in the engine. There's just too many things that can go bad, but bearings is number one. It'll literally take the top layer right off the bearings. Aluminums, it'll etch them and make a mess that you never heard of. What are aluminum? The replacement bearings for most of these 426 engines are these narrow, hard aluminum bearings. They did it for the 7080s and 7580s and somewhat of the 7060s, but they didn't have so much of the trouble. They had to make huge radiuses on the crank because they're structurally unsound. The radius was too light, designed back in the 60s, and they had to make a huge 3/8 radius. So they needed narrower bearings to make space. The bearing is a better bearing. It's a harder bearing. It actually, they found out because of the material, it wears better on the hard surface crankshaft, which, by the way, you can grind into the hard surface 10 or 20 thousandths. As an engine rebuilder from the way back, I have searched and researched, and if 10 under bearings are available, the crank's okay. If 20 under is available, the crank's okay, grind it. If 30 under available is available, the crank is okay, grind it. Your more important problem is the radius and the surface finish than you are the hardness of that surface. Because of the bearings and the oil, the crank isn't supposed to touch the bearing because of the oil. Just change your oil. You'll be okay. A diesel crank? No. A diesel crank remanufactured, you want an engine that's 10 thousandths and no more. And you do want one that either is replaced or has been ground 10 thousandths. Then you know that anything that might have been bad with it has been repaired. But you don't know that, do you? And I can guarantee you those rebuilders, you pull that engine apart, you're going to find different size bearing in there. And it ain't necessarily going to be 10 under or standard. So, oh what, the new Cursor Fiat engines? Not the old Cursor, the new ones that they're coming out with. They're calling it a blueprinted engine. Meaning if they screw up in manufacturing, there's going to be a different size bearing, and it's different for each individual engine. And a guy tried selling me on this, that each engine is blue. I said, that's bogus. Now, if every engine going down the line has the same different size main bearings, and every engine has the same number 1, the same number 2, the same number 3, all the way back to number 7, I'm buying it. It's a blueprinted engine. No, they're saying, no, they're screwing up in manufacturing. They're tired of paying for it. So you're going to find a 20 under bearing, a 30 under bearing, a 40 under bearing on the same crankshaft. And the next engine isn't going, you can't exchange internal parts is what they're doing. You can't go to a junkyard and just throw a crank in that machine, probably. That's part of what they're going for. And they're cleaning up the manufacturing. How do I know? GE, turning out turbines years ago, had a minimum spec in the spec range. But they also had an altered spec, where if something went wrong, they found porosity, somebody made a mistake, a tooling damage or whatever, then they turn it to this level, they mark it, and then they match the housing to the turbine. And it'll still function. But they need to know this is the range with this standard turbine. But it can go out, and if there's a turbine that they can match, the thing will still operate at this spec, but the housing has to be changed. And in some cases, they just weld the turbine, heat de-stress it, rebalance it, and return it because it might be just one mistake. But if it's an entire mistake that happens now and then, like I heard, because managers would come out and scream at people while they were machining and wouldn't allow them to shut the machine down, mistakes happened. And managers did that to people they didn't like. This is at GE as well as other places I've been. GE back in the 80s and 90s, these people were despicable. If they didn't like somebody, they'd go out and attempt to cause them to make mistakes to find a way to fire them. GE had to have a union, sadly. And that's the way with a lot of big corporations. Somebody got up to their position and suddenly they don't like you. And most often it was for lying, cheating, and thumping and covering for them. For lying, cheating, and screwing people. Mm-hmm. The morality of these situations changes a lot of stuff. Well, back then with Alice Chalmers, they sent bulletins through, they sent updates through, they explained things. And I talked to some of the service guys there, especially in the 1301 that I had. I seized it 3 times on a dyno, and you know what their fix was and their explanation? They kept calling back and telling us to measure everything. And the boss looked at me, and I said, what's that going to do? And he says, turns and looks at me. Well, you got to measure it. And I said, what's it change? And he looked at me and says, nothing. And he picked up the phone and said, tell me something. We've measured it. We've got numbers out the wazoo. I've seen the numbers. I've seen it. It's in spec. Installed in spec. And he says, so what's measuring it again for the 6th time going to do? And then a rep showed up and started smiling and made a few other small changes from the procedures I was following. He says, well, you didn't do anything wrong here. You just did something unnecessary. Really? He says, yeah. It's fine. Put it together. Oh, okay. The cure, a bulletin came through from Alice where the 7,000 had a block that was drilled for oil spray. But the engine itself was originally designed for standard bearings. There was no keyhole slot to feed the spray. He says, no, it's a 7,000. Originally, they didn't get it. We tightened our tolerances to quiet our engines down. Then we sent a bulletin out, but not everybody got it. He says, I got a feeling you missed yours, and it's not in the part system either. You put 70-10, 70-20 main bearings in the 7,000, spray oil on the back of the piston, your problem is solved. I had the pump sent out. They turned the pump down because that was cranking 115 or 20, some ridiculous horsepower. Just wild. Plus torque rise. And that didn't fix it the last time. So Alice came out, looked, and the guy says, yep, we'll put her together. You'll be fine. And at a certain point, he says, no, I'm confident you know enough of what's going on here. Put the thing together, and it ran beautifully. The only problem we had was we had to turn the idle up to 900 to 1,000 RPM because it would tag the warning light. It was a crankshaft-driven oil pump. And down near idle, the oil pressure would go down to 17. The trigger was 15. Hot idle. So I turned her up, so we were running about 20. And then as it broke in, all of a sudden the idle's up around 1,000 RPM, and he asked about that, and he called. This is turning 1,000 RPM now at idle. Did you? Yes. What do you mean? I said, I set it between 9 and 950 before it left. Well, that's high too. I said, yes. Well, do you want to? No. And he started laughing. Okay. Well, there's no problem here. It's just different. I said, yep. Normally it's 750. I said, we put new bearings in there, and your oil pressure at idle drops off. The instant you crack above idle, he says, I noticed my needle's jumping a long way. And I said, yep. At idle, anything below 1,000 RPM, you'll start to flash that little light. I don't like that. And so that's why you have 1,000. He said, okay, thank you. Hung the phone up. Because one of his things was I overhauled an engine before that in his other tractor, a 6080, I believe. And he says, it's running beautiful. There's no problem. You know what you're doing. Yep. Told him what the problem was with the 7,000. And then we moved from one shop to another. Then when we got there and the Alice guy looked it all over, he just says, oh, we made a boo-boo and covered it. Why? Because I had measurements. So there's a lot of stuff that can make a difference. Your engine, you're having trouble. Check your coolant. They have different coolant sticks for the type of coolant you're using. So talk to your supplier. If it's a Napa store for your supplier, you're going to have trouble. But push through them. Quite often they go up above, outside your dealer level, and you can get somebody up above and find out your information that you need to know. And not just one company can do your oil sampling. The oil sampling doesn't tell you anything other than there's no change from one to the next. And it marks where there is change or marks where there's something that's a number higher than they expect. And they'll tell you to change your oil and check it again. So that's another thing to do too. You see some problems that might be there, and this is a first or second oil change. Change your oil and filter quickly. Go back out, wait a while, sample it again, and if your sample starts looking clean, you'll say, but the samples are expensive. They might be, and the oil might be expensive. Can I advise you that there's quite a few engine overhauls on some of the modern tractors anymore, that a small engine overhaul is approaching $10,000 on a $30,000 tractor? Because now you don't have just parts, you have machining involved. And a tremendous amount of labor for it. And Kubotas and others that don't have sleeves in them, now you have boring involved. That's not it's an overhaulable engine. Well, think about it though. You're going to say, well, it's got to be bored. It doesn't have a sleeve. Yeah. Isn't that awful? Now you're 10, 20, or 30 thousandths oversized, bigger piston. Not a lot more horsepower, but it is more. So think on those things when you're going through it. But those are the stuff I ran into in the 7,000s that would have bled over into the 8,000s. Some of you others will talk about axles and cabs and steering and things, and you're all correct. The cabs fell apart. They were old, but it was a beautiful cab when it was right. The steering, they would leak now and then, but there's very little trouble other than leaks with the steering and the motor. So there again, these are a reliable, solid tractor even in the early phases. Most of the repairs and updates were done between the 7030, 7050, and the next series that came up through. So anyway, there you go. One other thing I think I ran into, but I was given bogus information. I think the last, going into the 60s, there was a run of 220s that came through with all-wheel drive that had the early version of the 7000 series driveline in it. Now, I haven't had confirmation of that, but there was one time, probably 25, 30 years ago, where I had seen a picture and heard of specifications of such a tractor. If you do find that, because they did have all-wheel drives of the original driveline version, if you do find that, send that information through to me and to Jason at Big Tractor Power. I can guarantee you that boy wants to know. Because we'd love to. Mike Less out there too, Farmhand Mike. We're just the type of people that would love to see this stuff. It's coming up on an hour. I spent enough of your time. Peace out, and you folks have a good day.